All right. Hello and welcome to Data Engineers Lunch number 114. Don't forget to like and subscribe, as well as turn on the notification bell so you can get notified every time we post a video or go live. Today's topic is Apache Iceberg Power Reflections, Query Accelerations Deep Dive by Alex Merced. In this session, Alex will unravel the mechanics behind Dremio's Reflections, a groundbreaking feature that transcends traditional materialized views, delivers seamless, transparent query acceleration. The organizer of this event is Rahul Singh. If you are interested in being a co-organizer or helping us get speakers, you can reach out to us at the marketing@anant.us email listed below. If you are interested in speaking or want to help us get speakers, you can drop an email there. We are part of a larger community, Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome and we expect respect to be given to protected classes. Data Community DC is made up of a number of different groups, generally centered around data. You can find out more about these groups at datacommunitydc.org, also dc2.org. Data Engineers Lunch, we cover the ingress and egress of data and anything in between, databases, ETL, data wrangling, and all the tools and processes of the data engineering world. If there is anyone new that would like to say hello, you can drop a message in chat saying who you are, what brought you here, what you hope to get out of this. And again, remember to like and subscribe. Our group rules are, if you have a question, ask it, be polite and courteous to others, and share what you know. We would like to give thanks to our program sponsors and our organizational and institutional sponsors. If anyone has announcements, jobs, meetups, hackathons, conferences at this time, you can also put them in chat. Data Engineers Lunch happens every Monday at this time slot. We also have Cassandra Lunch that happens on Thursdays. Our Anant Run books are still available. I will drop a link in chat, but you can get them on our website. All right. I will pass to Alex.
Hey everybody! I'm here again here at Announce That Engineers Lunch with a fun presentation. So first, let me share my screen, and yeah. So right now, you should see this QR code on the screen. This QR code I always like to share before every presentation, so that way, if you want to download the slides of this presentation, you can. This QR code will take you to a Google Drive where I store a PDF of all my different presentations. So not only will you find the slides for this presentation, but for any of my others. Generally, if you see any other presentations in there that you find interesting, probably I've done it here on Outside Engineers Lunch in the past, or I've done it other places. Just take a quick look on YouTube. You can probably find it. Um, but yeah, today I'm going to be talking about Dremio's Apache Iceberg powered reflections. So basically, reflections are a really cool feature of Dremio's platform. And one of the things that makes them work and so amazing is the fact that there's this thing called the Apache Iceberg that allows us to, one, recognize tables on a data lake, but also really kind of combines um, metadata and recognizing a table onto sort of one sort of like hybrid index data store, which we'll kind of explore kind of how we'd use that for query acceleration. But before we go there, a few a few announcements and few trailers, I guess, if you think of it like a movie. And first off, I'd always like to make sure you guys are aware that, again, I'm from Dremio. Dremio is the unified lakehouse platform for self-service analytics. And essentially what we do is we make working with a data lake or data lakehouse a lot easier, a lot faster, and a lot more open, sort of through three categories of value that we provide. One is unified analytics, where we basically allow you to connect all your different data sources. So you can connect your data sources like databases like Postgres, MySQL, etc. MongoDB. You can connect data lakes, whether it's AWS, ADLS, Google Cloud, Hadoop. You can connect your data warehouses such as like Snowflake and Redshift, and be able to work with all that data in one nice, easy to use place with a semantic layer to organize that data. So that way, no one has to really, your end users just focus on getting the data they need, and they're not necessarily having to be horribly concerned with where that data is physically stored. And with that is an SQL query engine that allows you to federate queries across all those different data sources. So I can go join a Snowflake table with a table in Postgres, or join an Iceberg table on AWS with an Iceberg table on Azure. I have also possibilities are are infinite with what you can do when you can just have access to all your data and query it all from one place instead of having to move all your data from place to place. And then last, lakehouse management. It Dremio is heavily designed for helping execute an Apache Iceberg lakehouse. So in that case, it has a enterprise catalog built in that allows you to do like catalog versioning. So you can do think like Git like operations with your Iceberg tables and your Iceberg, not just one table, but with multiple tables at a time, creating branches, tags, but also servicing of those Iceberg tables, whether it's automatic compaction, expiration of snapshots. So that way, basically using Iceberg tables on your data lake feels just like using a data warehouse or a database. It just kind of works. And that's the beauty of what the Dremio Lakehouse platform provides in its unified analytics, SQL query engine, and lakehouse management. And because of all that, it is able to access your data sources in the cloud or on-prem, allowing you to create a hybrid Iceberg lakehouse. Okay, where basically you can work with your data wherever, whatever environment it is, and actually join them together. So you can join on-prem tables with your cloud tables and govern them, document them, craft that semantic layer, all from one platform. But with that, again, I'm Alex. I'm Alex Merced. I'm a senior tech evangelist for Dremio. I'm also the author of Apache Iceberg, the Definitive Guide, which is a new book from O'Reilly about Apache Iceberg. You can get that book for free by scanning this QR code right here. And on top of that, right now, I'm doing an ongoing Apache Iceberg crash course. So it's 10 sessions. We're 3 sessions in. This is running from July 11th to October 29th. You can still register and catch the course, the lessons that have passed on demand and be there for the future ones. But it's a very in-depth sort of overview of what Apache Iceberg is, how to work with it on different platforms, such as Apache Spark and Dremio, what all the different terminology means, the architecture. It's a real deep dive. You'll have a much deeper understanding of Apache Iceberg and its role in data lakes and data lakehouses after going through these 10 sessions. And again, you can register that through that QR code right there. I'm also the host of several different data podcasts. So as you can see, I do a lot of talking. Okay, I aim to always educate, entertain, and enlighten wherever I'm at. So if you want to hear more about different data topics, you have all these podcasts you can subscribe to on iTunes and Spotify. You can find all my social links at this URL here, so that way you can follow me on whatever platform you prefer. But with that, no further ado, let's get into our featured presentation. And essentially, when we're talking about query acceleration, we're really talking about what happens when you start pushing your query engines to the edge. Okay, so every query engine has a certain amount of speed and performance, and then you get to a point where you scale up so big, the data sets get so large, the queries get so complex, you start seeing the outer edges of that performance. Okay, so Dremio provides some of the fastest price performance in the market, but even then, as your data sets get bigger, as your queries get more complex, you'll start seeing sort of, a longer latency. So what do you do to improve on that latency, whatever system you have? Okay, because again, what happens is data to get larger, it takes longer to process the data because you're opening up more files. If we're talking about data lake tables, having to process things like group bys and joins take a lot of time. If we're talking about big, massively parallel systems, so you're constantly shuffling the data from one node to the next, so that movement of data from one computer to the next takes time, and organizing all that. The limitations of memory on the actual nodes, all this stuff is going to affect the performance. And there's different ways you can deal with it. Okay. And traditionally, how you deal with performance, you do things like indexes, right? So you create like a separate data structure that gives you information about the table so you can query the table faster. Where there's like, just a normal value index that says, okay, hey, this is where the first record of this value starts. Or, here is usually something like a binary tree or something like that. But essentially, it's information about the information that allows you to scan the information, essentially metadata. Okay. But an index, the only catch with an index is that that index has to stay up to date. So anytime you change a table, anytime you write to the table, you have to write to the index. So that's going to affect latency because now you're adding additional work on your writes. So if you have too many indexes, that gets kind of expensive. But that works. You can speed up a query with indexes. And again, it has to be based on the underlying structure of the table. So every database kind of has their own way of writing an index based on sort of the way they store the table under the hood and so forth. Then there's materialization. So this is like a materialized view where you say, okay, hey, right now I'm running this query on the table. It takes so long to get that final information. How about I create a materialized view on that result set. So that way, next time I run a query or run this query, the results are already pre-computed. Okay, essentially, we're just creating a physical copy of that result set. Okay, and giving it a name like it's another table. And that works. The question is, like, how do you keep it up to date? Because the table changes, and not in all systems, if the table changes, does it go back and then change any materializations or materialized views you've created on the table? So then you have to kind of make sure you keep them in sync. And like, how do you keep that in sync? Like, do you maintain like a write log so that we're only capturing the changes to more efficiently update it? Or are you recomputing the entire materialization? All these things generally have to be figured out as a data engineer, and you have to coordinate these things and make sure that they run performantly to meet your SLAs. It can get complicated managing all that. And on top of that, you're creating another name. So it's no longer querying table B. Now you're querying like table B something materialized. Okay, there's a new name, and there might be like 10 different materialized views you make because there's lots of different queries coming in and you're optimizing for different types of queries. And now analysts need to know which version of the table to query to get the right performance. Okay, so they might accidentally query the original table, even though you created the materialized view, and they'd have a slower query. They might query the wrong materialized view and get a slower query because it's not optimized for their particular query. So there's some catches there. Then there's like results caching. Okay, and this is just basically, you're not creating a separate materialized view. You're just taking the results of a particular query, and if that same query comes in, you have the results already saved, so you just give them back those results and then have some sort of logic on when those results become no longer, where you invalidate the cache. So it might be like, hey, if we notice that the table changes, then invalidate all. But again, if it's not built into the system you're using, it's something that you would then have to sort of implement on your own and create some sort of abstraction over the tools you're using. All of this requires sort of a lot of engineering work. So Dremio figured, okay, how about we solve the problem not by just choosing one of these approaches, but kind of implementing a little bit of all of them into one solution that's kind of automatically managed by the Dremio platform, so you don't have to worry about it. Like a lot of that work that takes in implementing those solutions is just not there. You just literally create a thing and it just works. Okay, that's always sort of the Dremio goal, to make things just work. Okay, it's all about that easy and fast, trying to eliminate those trade-offs. So what you end up with is a reflection, which is a mix of, using an index. So basically what it does is that you take a table or a view of that table and you reflect it. When you reflect it, what it does is that it creates a materialization as an iceberg table. So what you're doing is that, it might be a Postgres table I have connected to Dremio. If I turn on reflections, then on my data lake, an iceberg table is made that is essentially a materialization of the data, a physical copy of the data. But because it's an iceberg tables have two parts. There's the metadata that provides me information about the data to more efficiently scan it. So that kind of functions as an index, allowing me to scan that data more effectively. And then there's the actual data files. So that's the actual materialization, the actual physical representation of the data. And that's done in Parquet. And you get all the benefits of Parquet, as far as like row groups, and these are very optimized Parquet files. So when you combine the metadata, again, which is acting as an index on the data, and the optimized physical representation, you're getting sort of both in one. Okay, so then anytime the reflection updates, that metadata and those files get updated. Okay, so again, you take a table or view, and the cool thing about it is that it doesn't create another name. So if I create a reflection on table B, my analyst can just keep querying table B. And what's going to happen is that Dremio will evaluate it. Okay, so what happens is that a query comes in. As far as the analyst needs to know, they're just querying the same tables that they've been using all along. But Dremio is aware that whoever the admin of the platform is, or the data engineer who's doing the engineering behind the scenes, has created these reflections on that table or view. And it'll say, okay, well, I have these like 5 reflections that are built on this view or are applicable to this view. And then it'll quickly look through the structure of each one and say, hey, which one of these is best suited for the query that came in, to get the fastest query possible, and then substitute it. So in this case, the analyst doesn't have to worry about accidentally querying like the wrong version of the table. They just query the table, and Dremio figures out which is the sort of the right materialization to use when these materializations are needed. And again, a lot of the times in the Dremio platform is super, super fast. So in that case, a lot of the times, most situations, you probably won't need reflections. This is for those situations where you sort of do need that additional oomph, a little extra push to your query performance, especially as you scale up and up and up. Okay, so it's a really cool feature, but the Dremio platform itself is fast enough that it's not something you have to use all the time. Now, generally reflections are put into sort of two categories. So there's two types of reflections. There are raw reflections, and then there are aggregate reflections. So raw reflections are like more like materialized views. They're just sort of a physical representation of the raw data, the rows of records. Okay. While an aggregate reflection is more like a BI cube. So cube would be sort of pre-computed aggregates. It's not a physical copy of the rows of data in the original table, but it's basically a physical copy of the pre-computed like min, max, average based on different dimensions and measures. Now, those are the two types you can generally choose from when you build reflections. Now, in certain situations, you find there's a couple other types. There's like snowflake reflections. So if it notices that sort of like your data is modeled in sort of a snowflake schema, it'll just affect the way that it builds out the reflections to optimize and take advantage of that modeling. Then there's external reflections, which allows you to create physical representations outside of Dremio and then register them as reflections. So that way, if you already created your own manual materializations and you want Dremio to consider them, you can register them with Dremio, and Dremio can use those if you prefer, in case you have to use some sort of very sort of custom process or logic or something like that. I would say vast majority of the time, you can just flip a switch, turn on raw and aggregate reflections, and that's going to work pretty well. And the cool thing about reflections is that they're really easy to create. Like the Dremio UI has basically some buttons and knobs you can turn on to enable reflections pretty easily. We can also just do it through basic SQL. Okay, so there's SQL language in Dremio that allows you to create these reflections. So you can see here, I just alter a table. I'm going to create a raw reflection. And I get to customize how that raw reflection gets made. I get to say, okay, hey, I don't have to materialize every column. So if I have a table with like 100 columns, I don't have to, a really wide table that I want to accelerate, I don't have to create a materialization that has all 100 columns. I can save myself the space by just specifying the columns that I really need for the queries that I'm optimizing for. And then I can actually specify how that raw reflection is partitioned. So I might have it partition different reflections, partitioned different ways for different types of queries. So imagine like a data set of like voters. I might create one reflection that's partitioned by like political party, and then another reflection that's partitioned by state. So that way, depending on what kind of query is coming in, it'll use the right one. And then you can choose how like it sorts the individual data in the files. So in this case, it's partitioning, it's breaking up the data by country. So the United States will have one partition, Canada will have another partition, and then within those data files, the data in those files will be sorted by last name. Okay, and then that'll create that reflection that can then be used. Now to create an aggregate reflection, it just looks just like this. Okay, and here I just specify, hey, I want it based on this table. But again, what matters here is dimensions and measures. So I'm going to say, hey, the dimensions I want you is the state. And the measures I want you to optimize for are count. So in this case, I'm only looking for the count of cities by state. So literally the reflection would just be each state. So like how many cities are in Nebraska, how many cities are in Connecticut, how many cities are in Texas, and just be that in there because I've only specialized one measure and one dimension. But it's pre-computing those, and now if I have a BI dashboard that's leveraging that, it'll be super, super fast, super crisp, working directly off that table. And again, the analyst doesn't even need to be aware that you created these things. They're just going to notice that when they create a BI dashboard on that table, or they create reports on that table, they're just faster than they were before. They said, hey, can you make this faster? Couple clicks, it's faster. And the cool thing about the SQL approach is that Dremio has many ways you can send SQL to it. You can send SQL to Dremio via REST API. You can send SQL to Dremio via Apache Arrow Flight if you like using Apache Arrow, or JDBC ODBC, which makes it really easy to programmatically automate a lot of this stuff because you can just write scripts that automate it, send the information, send the SQL over to Dremio, and Dremio runs these processes. Okay. Now let's go a little bit deeper into like how raw reflections work. So there's raw reflection. So again, I have a table, and then I can specify like so this one is like this particular table has 50 columns. Okay, so it's 50 columns, but I'm only materializing 5 columns. So in this case, when I create a reflection, I said only reflect these 5 columns because those are what my queries are doing. And I want you to be sort them by this field and partition them by this field. So I have like that flexibility to kind of customize how that thing turns out. And I can create multiple reflections. And again, Dremio will evaluate each one to determine which is the right one for the right query. So that way, analysts just put in their queries and they can just enjoy the performance. Dremio will handle the heavy lifting. And then it will also even handle the heavy lifting of updating these reflections. So you can generally set a cadence on when to update these reflections. And you can also just manually trigger a reflection. So in those automations, you can automatically trigger sort of a reflection refresh. Okay. Now, again, you can choose which columns are materialized. You can choose how those records are sorted and how it's partitioned in that reflection. Okay. An aggregate reflection is again built for like more like for like BI use cases where you're doing a lot of group by type measures. So you're doing a lot of aggregations. So you choose which dimensions. So again, in the example before we saw, like I chose a dimension of a state. Okay. And then so that'd be like group by state. And then which measures would be like what I do, like select count of cities. Okay. So basically I can, so basically the measures are the different metrics that I'm optimizing for in that particular data set. And basically what you end up with is I might have table A, and then when I create the reflection, what I'm really creating is something that kind of looks like this. Okay, so I might have the different metrics up as fields, and then like the rows will represent the different measures, and you get a nice sort of table of all these pre-computed metrics that can be used to accelerate queries that are taking advantage of those, like particularly BI dashboards that are taking advantage of that. Okay, use cases. So what are different situations you might want to use reflections? Now, again, it's not always just to accelerate. Sometimes it's to offload. So what do I mean here? So maybe I have a Postgres database. And in this case, I have a Postgres, a Mongo, and a SQL Server database that I have connected directly to Dremio. So when you connect these sources directly to Dremio, it's initially going to push down a query to initially get the data from that source. Okay, that's fine. Where you might run into an issue is, what if I have a lot of other queries for like operational purposes that are also hitting this Postgres database, this Mongo database. So you're not having sort of a competition between different queries for the capacity of that server. What I can do is I can offload that by reflecting the tables. So I still want my analysts to feel like they're just working with the Postgres database. I don't want them to feel like there's another table somewhere else. I just want them to log on to Dremio, query the Postgres table, query the Mongo table, just feel like that's what they're accessing. By turning on reflections, Dremio under the hood is going to create that copy in the data lake, that iceberg copy in the data lake, and substitute it when those queries come in. But from the user's point of view, they're just still querying like Postgres.table name or Postgres.database.table name. And they're not aware of it, but those queries are no longer going to push down to the underlying system. Okay, so now basically you're not going to have that competition of that system having to handle queries coming in 2 directions. And then you can just refresh that reflection on a cadence, and basically the analytical queries now become offloaded onto Dremio in the data lake without there having to be this explicit, breakup in the sense that we're like, now the analyst has to kind of think, oh, I have data here and data on the data lake. To them, they're just experiencing the data is where it was when they interact with Dremio. So that's one use case. Again, that offloads and helps you scale capacity of your underlying systems. Another way to do it is that in Dremio, you're often doing a lot of the modeling in Dremio using views. So you're doing virtual modeling. Okay, so you're not creating physical copies for your bronze, gold, silver. Your silver layer and your gold layer are often made up of all these virtual logical views. So in this case, I might create a view that is essentially a join of tables from these three systems. Now, if I were just to query the view, again, it would push down, it would have to recalculate that join every time. So it would push down to Postgres, push down the Mongo, push down the SQL Server. But what I could do is that instead of reflecting each of the original tables, I can just reflect the join. Because pretty much all, maybe we're going to assume here that all queries otherwise are really just based on the join data once it's been denormalized and modeled and all that fun stuff. So in that case, let me just reflect that layer. So I can reflect the join. And again, from the end user's point of view, they just query that view as if it were any other view, but to them, it's basically the result of this join. But during behind the scenes, it's managing that reflection of keeping it up to date and substituting it as queries come in. And this gets even better. You'll see in a couple slides. Okay. For example, if I have that join and I have several views based on that join. So in this case, I have like this view, this view, this view. When I query this view or this view, it knows, because Dremio has a built-in semantic layer, so it's aware of the relationship between all the tables. This is what enables features like lineage and search and a lot of the other features that Dremio has. But essentially, since it knows that this view is a child of this view and that this view has a reflection on it, when I query this view, it'll automatically use this reflection will substitute it if it makes sense, like if it will actually accelerate the query. So in this case, this reflection doesn't only speed up performance on this view, but it will speed up the performance on all views derived from that view. Okay, so essentially, it's aware of all the children, it's aware of your sort of tree of objects, and allows you to reuse that reflection as often as possible. So that way you get the best bang for your buck on your materialization. Okay, so that way you're not having to create a materialization for every view of the table. You can strategically create them in ways where you're going to get maximum reuse. So you minimize the cost of recomputation of storing those reflections. Okay. And then again, when you're using it for like BI dashboards, this is essentially like the pattern. Essentially, you would connect a tool like Tableau or Power BI. Like there's literally like a Tableau and Power BI button built right into the Dremio UI to quickly connect to those directly from Dremio. Any particular data set you want, but it also works with like Apache Superset and several other different tools have integrations with Dremio. But essentially what they would do is that query would come into Dremio. Dremio would recognize that it's like an aggregation query and substitute the aggregate reflection when it notices that, giving you a much faster BI dashboard, probably one of the most popular use cases. Because it's nice to kind of have a fast BI dashboard that's working directly off your data in your data lake, because it allows you to deliver that BI dashboard a lot faster and develop it a lot faster, because you don't have to move it as many places, move it into a data warehouse and then model it and all that fun stuff. You can just do all that in your data lake. So that's quite popular. But there's a lot of enhancements. Like Dremio is putting in a lot of work and taking this reflections feature to the next level. Here are some of the features that have just recently, over the last year, have been introduced to make this reflections feature such even more groundbreaking, even more amazing, such as incremental reflection updates. So as people move towards Apache Iceberg based data lakehouses, oftentimes your source tables will be Apache Iceberg tables. Okay, not just your reflections, but the actual source tables. And when that is the case, so basically, if I were to have like a bunch of Iceberg tables that are my raw layer, and then I were to model off of that a bunch of views, well, as I create reflections on my views, since the original data, the original raw tables are Iceberg tables, it can now update those views incrementally. So you get much faster reflection updates, much cheaper reflection updates, because it can capture the deltas and then update them based on those deltas. Okay. Another thing is that sometimes people just don't know when to use use reflections. So like, okay, I have all these views, I have all these tables. I get what reflections does. It's a really cool feature, but I'm not quite sure when I should use it. Either they don't use it enough, or they use it too much and they create a lot of reflections they don't need. So to help with that, Dremio has added a reflection recommender. So the Dremio cluster will now observe your query patterns and take the guesswork out of it. Now it'll just tell you these are the reflections based on your queries and your query history that are actually going to benefit you. They're actually going to increase performance, save you money, and then it'll actually tell you, hey, these reflections you don't need anymore. So in this case, it really makes everything a lot more automatic. You just basically let people query the system, and then Dremio will tell you, okay, hey, here's how you can optimize, taking a lot of the work out of it. Now, of course, there's always edge cases. So to help with edge cases where you may want to like disable reflections for a particular query or point a particular query to and explicitly to a particular reflection and other situations, there's a feature called reflection hints that allows you to kind of put little instructions and comments in your SQL just to kind of be more explicit. More features around reflection scheduling. So when you refresh your schedule or refresh your reflections, so it's easier to manually trigger it, but because there's like SQL statements around it, the ability to kind of set a particular cadence in the UI, a lot of features, new features regarding helping set that schedule more easily. So yeah, no, reflections is a really cool feature that gives you a lot of bang for your buck. But honestly, right now you've heard me talk about it, but the best thing to do is kind of get hands-on, not just hands-on with reflections, but hands-on with the data lake and the data lake house, hands-on with Apache Iceberg. And here we have several tutorials where you can do that. This first tutorial here is if all of these will help you set up a lake house environment on your laptop. The first one is probably the easiest one to do. It just sets up the environment. You run a few queries. You see your files get generated in your data lake. It's all self-contained in Docker containers, so no cloud infrastructure is needed for any of these tutorials. Now, these 3 tutorials, you start off with a source system like a Postgres, SQL Server, or MongoDB, and you get to see the whole process of like connecting that to Dremio, and then being able to ingest the data as Iceberg using Dremio, and then serve a BI dashboard using something like Apache Superset, all in one exercise that you can do pretty much in like 40 to 50 minutes. Only caveat is like for like these 3 exercises, if you might want to make sure that your Docker engine has been allocated at least like 6 megs of RAM. Just as a note, just because you're going to be running like 4 or 5 containers. So just a little note in case you have like less memory and you run into an error spinning up the containers. This one should run pretty much anywhere because you're only spinning up 3 containers. So those are all really good exercises that help you get hands-on. I'm also the host of Gnarly Dataways, which is Dremio's bi-weekly web broadcast where we have people from all across the data lake and data lakehouse space come in and talk about their different solutions. Customers kind of talk in about how they've implemented their data lakehouses. A lot of really great episodes. You can find all of them on YouTube, Spotify, iTunes. Highly recommend subscribing to the podcast on Spotify or subscribing to the Dremio YouTube channel at youtube.com/Dremio. And I travel a lot for a lot of events. I'm constantly speaking. So I do run this Slack channel called the Data Lakehouse Community, where I have different Slack channels for different like cities that I travel to a bit. So feel free to join this Slack channel by scanning this QR code and joining the meetup channel for your particular area to meet other people in the community in your area, but also to find out about events in your area. And with that, any events that I'm going to be speaking at, whether it's virtual or in person, me and the rest of the Dremio evangelism team, you can scan this QR code to take us to our Luma calendar where we're going to be tracking all that you can subscribe to, so that you can just get notified wherever we're going to be in your neighborhood. But with that, that is the end of the presentation. I hope you guys all had a good time. I'll now open it up to questions and see if there's any questions that anybody has.
All right. Yeah. Thanks for another great presentation, Alex.
Thank you.
We have one question in chat from Eric. What do you recommend in supporting Apache Iceberg using AWS or a cloud or a SaaS service?
I mean, it depends what aspect of Apache Iceberg. Like, any storage layer works for the most part. Like, I mean, whether you're using like AWS or ADLS or Google Cloud Storage, or using an on-prem solution like a VAST, a NetApp, a Pure Storage, or a Minio. The thing to consider is just sort of like what your specific setup is. So, for example, if I'm using a lot of AWS services just in general already, then AWS makes maybe more sense for where I store those Iceberg tables. Now, in situations where you're not like really nestled into sort of one environment, so maybe you have a little bit of Azure, a little bit of AWS, this is where like a Dremio becomes a really good platform for your Iceberg Lakehouse, because I mean in general it works because it's got that price performance. So basically even over built-in systems in many cloud platforms, Dremio is going to offer you cost savings just because of its performance. So you're spinning up less infrastructure because you're serving queries faster, and generally Dremio can execute the same query with like less infrastructure to begin with. So you get that what's referred to as price performance. But again, especially when you're doing cross environments, that's where Dremio really excels, because Dremio can connect multiple clouds and on-prem. So if you have where a lot of situations, a lot of companies have some data on-prem, some data in the cloud, and it's a challenge. Like they have to move the data from one location to another for different use cases. You could put Dremio on top top of that to help unify that, making it a really powerful tool because Dremio is so Apache Iceberg centric. It really makes it a powerful tool when you're doing an Apache Iceberg data lake in whatever platform to do that. But otherwise, like any tool works. Like things I'm excited about, like I always love using the Nessie catalog when it comes with that with any tool, because Nessie is an open source catalog that allows you to do all that Git like functionality. What'll be exciting is to see what Polaris looks like. That's going to be the new catalog from Snowflake. That they're doing in as open source. So that'll be really cool to hear when we see more details and more code of what that will look like. I will definitely be doing my best to take a look into that and create some tutorials around it to help people try it out. But yeah,
Cool.
no, I mean, the great thing about Iceberg is that there's a huge ecosystem. I do think Dremio is probably going to be the most versatile tool, just because it connects to so many different places and has the performance that it does. So generally, it's pretty valuable. And again, you can try it out for free using these QR codes. You can just spin it up on your laptop and try it out and see it for yourself. Now, as far as other cool tools, again, if you're in Azure, you could be using like Fabric and using Fabric notebooks to do a lot of work in Iceberg. You could, if you're in AWS, you could be using like Athena. Again, I do think there's still in that a value using Dremio. This helps speed up your BI dashboards and whatnot. But generally, all these platforms have building Iceberg functionality within their tools. Whether it's like again BigQuery, Athena, the Fabric notebooks and whatnot. And again, if you have on-prem data, then Dremio's basically a must-have at that point.
Mhm.
Any other questions?
Yeah, next question.
Yeah, go ahead. I'll go last.
Sure. Next question is, will there be any data integrity issues as you create more materialized views on top of the actual tables?
I mean, I don't want to say there would be any data integrity issues because again, it's all Iceberg. So essentially, what happens is that either the transaction succeeds or it doesn't. So you do get asset guarantees, where you have to be careful of is in your reflection refreshes. Okay, so if you're talking about like if you're ideally you don't like, let's say you have like a 3 petabyte table, you don't want to reflect the 3 petabyte table because the reflection refresh will take a very long time. So ideally, what you do is you create views for the individual use cases. So again, you take advantage of Dremio semantic layer. You do your modeling. So like even before you do any reflections, you should always just do your modeling first on Dremio, create all the views you need for your different use cases, and then generally like you're going to reflect either in like that sort of that silver or that gold layer, where basically it's hey the actual data for that particular use case, and reflect it from there, because those reflection refreshes will take a lot less time, assuming the data is not the underlying data is not Iceberg tables. Like if the underlying data is an Iceberg table, well then you're going to get those incremental refreshes, so that becomes a lot less of an issue. So if you have like a 3 petabyte Iceberg table and then you reflect views underneath that, again those refreshes are going to be incremental, giving you again a lot less issue. But again, you want to always work backwards. First, model your data. Two, then determine what your SLAs are. Okay, so because basically, like for example, if this table is being updated very frequently, and you want the freshness of the data that people query to be real time, then probably you're going to want to take a different approach to accelerating, because the time it might take to make a refresh. But let's say, um, you know, depending on the size of the data and whatnot. So first you'd figure out how long does it take to refresh, and then you would compare that to okay, so if this refreshes, this takes much this time to refresh, you might have like less like latency in the data. Let's say like 5 minutes. Is that okay? And you determine that, and if that works, that's a good solution. So this is kind of like the same approach you would take with pretty much any solution, in the sense where you first model what you need for your use cases, determine sort of like what are your needs. And a lot of people tell you, hey, they want real time data, but they don't necessarily need real time data per se. So you want to make sure to figure out, hey, what are the actual business needs? Like what serves the business use case and gets to and then you design from there. So you figure, hey, what is the right size view? What is the view I need for this particular use case? Now, if I create a reflection on it, how long does it take to refresh as frequently as I need it to refresh? And then you can kind of engineer from there. Again, Dremio's reflection recommenders will help with a lot of that. So a lot of that you can just kind of let Dremio figure it out for you, and that's going to be continue to get even more and more advanced. So ideally, you can already think about it less because of the reflection recommender, which will figure out a lot of these details for you. And in the future, that will only become more and more sort of hands off, and just sort of work. So that would be my sort of take on there. Like, you shouldn't have any issues where basically, hey, like you get a partial refresh. It's either refreshed or it isn't, because it's an iceberg table. So it's either the transaction is complete or it isn't. So you have those asset guarantees. So worst case scenario, if like you have a reflection, you have a really big table, and then that reflection refresh takes, like, let's say, 10, 20, 30 minutes. It might either be querying the old reflection or doing, I think it would probably, or even just requery the data. Depends on the situation. But again, what I would do first is do everything without reflections, because again, I would say probably the majority of your use cases, you're going to find that you won't need them. Dremio is really, really, really fast. It's just out of the box, it's just fast. And then you determine sort of where are those sort of rickety joints, the places where you might need that little push, and you work backwards from there. But start with the views, start with modeling everything virtually, and then work backwards. That would be sort of my advice. Again, if you're engaging with Dremio, Dremio solution architects can better help you find a specific solution, as you architect your specific implementation, and they can take a look at your particular data, your particular needs, your particular setup of nodes, whatnot, and give further guidance. But off the top of my head, that would sort of be the way I think about it. There's another question.
No more in chat, but I actually had one or two.
Mhm.
So first, to clarify, reflections are new Iceberg tables, essentially. Creates them and it stores them in Iceberg table format.
Yep.
So the question is sort of, how much query acceleration are you getting in this sort of worst case scenario where your data is already in Iceberg format? Like
If
it's
your data,
doing.
Yeah, I mean, ideal world, your data is already an iceberg, because then you'll probably need reflections even less, because you're already going to have the benefits of iceberg. Where you'll be creating views in a situation where the underlying data of the iceberg is not on the table itself, but on the views. So you might have, let's say, like again, giving a really big example, let's say like a 10 petabyte iceberg table. Okay, but you might have a view that's only a view on like 1 gigabyte of that data. That's where the reflection will be useful. So I can create the reflection, and the nice thing is that reflection can then incrementally update. So it's almost real-time freshness at that point. So essentially, like 10 petabyte table updates, you get this really low cost, or very minimal cost, super fast update to the underlying reflection, and then whatever use case that view is working off of it's going to stay really fast and really fresh. So that's sort of like ideal world, where basically your underlying data is Apache Iceberg tables, and then you build up from there. Because one, you won't need reflections as often because it's already an Apache Iceberg. So you're already getting the benefit of sort of the metadata index and whatnot. But and then you get the incremental updates when you do need the reflections.
We actually got sort of a clarification on the last question. Specifies, since one column may be present in multiple materialized views, one can refresh quickly and the other might have already completed, or one may be refreshing and the other might have already completed the refresh, and therefore you can get different data from the two queries.
I'm not. Yeah, I'm not sure if that sounds like it was more like a statement, probably like more of a
Yeah.
clarification than it was a question. But yeah, no, I mean, Dremio's underlying engine is pretty smart regarding like the reflections that are available and the data that's already created, so it can really optimize how all of that. So again, there's a great article from Benny Chow, who's one of our main engineers working on reflections, that are on the Dremio blog, where he goes much deeper into how like that matching logic and all that works. And he also did a great presentation at the recent Apache Iceberg Summit, and those go much deeper into with the actual sort of like the actual engineering side of how all this works under the hood and how it does all that matching. So for those who really want to kind of go really deep under the hood and see how all that works, I would definitely recommend those pieces by Benny. to go to like the next layer of depth of how this feature works.
Yeah, I might look into those because I actually had a question. How do you determine which reflection you send a query to? Like if you
Um,
have two different reflections that could theoretically service this query,
there's
what
actually a really
decides
good
between that?
example of that in Benny's article, so I'll refer people to that because he
Okay.
actually shows like the screenshots of like and the logic. It's pretty good. It's pretty cool.
All right, cool. That's all I had. Roll.
I've got a couple questions. So actually, I'll say there are two categories of questions. We'll start with one. So often, and I think I know the answer, but often when we're dealing with indexes or materialized views, it is possible to make a bad index or a bad materialized view if, for example, you do an index on, maybe it's like a true or false. Like the column is either true or false. So, is that something that's magically solved by Iceberg format or with Dremio's metadata index, or is that still going to be a problem if people make bad indexes?
I mean, you could still make bad, like you could like you still want to think about what your query patterns look like. So again, if I'm making a reflection specifically and I'm specifying the partition logic, I want to make sure I partition it by a good partition field, meaning it's something that one, people are querying specifically in majority of their queries, and two, has like not low cardinality but not high cardinality either. It's like not everything shouldn't be a unique value, but it shouldn't be like two values. So that we can like avoid like skew. So that's still an issue. That's where the reflection recommender becomes really helpful because it can help identify those things and make those mistakes a lot less likely. Iceberg's metadata, I do think, helps minimize some of that damage because you're not in other systems. You're going through all these file listing operations to kind of like go through all these directories of files that can be kind of expensive and time consuming. Well, in Iceberg, all of that's done strictly within the metadata. But again, if you choose the wrong partition values, you might end up getting like the number of manifest files and data files you get will still extend the latency. I don't think as much because it can still more effectively plan through the metadata, but you're not going to get the benefit you would get if you choose things like partitioning and sorting based on what people are actually filtering by. So at the end of the day, like you still want to know what people's queries are. And again, that's the reason why the reflection recommender was created to help make that particular task much easier.
Got it. Yeah. And actually, I had a follow-up question this is not the second category, but so there's often, you'll be happy with a materialization of a query, and you may want to serve that up as a REST API. How performant is a materialization in terms of, is this something that, and this is I'm asking this because a lot of people in the data warehousing, data lakehouse world will claim, oh yeah, you can throw anybody on this API or query and it's going to be great for millions of users, which is bullshit because it's not true. What is the performance? Let's say if I wanted to expose a materialization or a reflection rather as a REST API, and it's going to be end user facing, like through some API gateway or whatever.
Yeah.
Is that an anti-pattern, or is that actually very possible with Dremio?
Yeah, we have a lot of customers who do stuff like that, where they basically will do all their modeling in Dremio, and then they'll build like another application on top of Dremio. So most of the end users don't even realize they're using Dremio because they're using this sort of like abstraction that the company made internally on top of it. And then they're using Dremio to kind of unify all their data, and then reflections where needed. So at the end of the day, like Dremio itself will be fast enough that should work, and because Dremio's not like basically the store, like where the data is physically stored in the compute is separate. It's infinitely scalable because essentially you can, like if you're using Dremio Cloud, you can set up rules for it to automatically spin up more clusters to handle your expected concurrency. And you can actually create rules saying, okay, hey, I only want 5 clusters at a time, but hey, if any cluster is like not doing anything for like 60 seconds, shut it off. So that way you're only spending what you want. but it can scale up to what you need. And again, even then, like a individual Dremio cluster for like the same amount of computing power is generally going to be able to do more for that unit of computing power than most other systems. So that's where the price performance is. So you can always get the performance with any system if you scale it up enough. The question is like, okay, how much scaling do you need? How much do you have to spend to get to that performance? Dremio is going to sort of have a pretty compelling story there, because of the way it's architected. Because it's not just about the reflections. Like the reflections are a nice thing that you put where you kind of need it. I always think of it like if I have this like really large complex system, there's a couple places that need a little oil, like a little WD-40 to move smoothly. That's reflections. But more fundamentally, Dremio was built up with Apache Arrow from top to bottom, as far as its processing. Even before really like Apache Arrow was even like Apache Arrow. And so basically, it's really built using open standards and Apache Arrow not only allows you to process data faster in memory, which Dremio takes full advantage of, but it also allows you to transport that data faster when you're using things like Apache Arrow Flight. So you get those additional benefits. There's another feature called the columnar cloud cache, where Dremio will cloud cache on those nodes assets that get frequently accessed from your storage, and all of these things help it get that additional sort of performance, plus several different layers of query optimizations and stuff like that happen as well. So it is scalable for that kind of a use case. That's actually probably what a lot of people use it for, because it's a platform where you can scale up unifying the data. But at the end of the day, like chances are, like depending on what your concurrency needs are, there is a discussion of, okay, hey, what should the infrastructure look like to hit that scale? And that's always like, you have to like if you just set up X number of nodes, but that's going to be able to handle X. But if you really wanted Y, then you have to make sure you set up the infrastructure for Y. Again, you're going to get a better amount of infrastructure with Dremio, but it still requires you to be sort of honest. Okay, hey, what is it that I expect coming in, and to set up your infrastructure the right way. Dremio makes that really easy, especially on cloud, where you can again set up those rules, and Dremio will just adjust the infrastructure for you. Yeah. So yes, but again, there's always like little nuances to the execution, and I don't want to necessarily say, hey, you just flip a switch and everything magically works, but it's pretty close.
Yeah, I think it's worthy of kind of a benchmark to compare, because this is ultimately one of the problems we end up solving is like, okay, we have 1 million users using a mobile app. Where do I put this information? And it's like, yeah, you could actually, if you can query it using a unique ID, you can put it as like a S3 object, honestly,
Yeah.
Perfectly fine, versus like an iceberg row or like a Cassandra partition or something. Like it really, it's a matter of like, what's the goal? But the moment you start doing queries, go ahead.
Yeah, no, I mean, if you're querying an iceberg table, I mean, it is really just objects sitting on your S3. So it's able to handle, that's part of what allows Iceberg to scale so infinitely. And then if it's a really small data set that's like one Parquet file, then you could just be one Parquet file. Dremio could still query that and give access to that. So again, you have that difference between sort of like, hey, what is the scaling of the storage layer, which is independent from what Dremio does, and then the scaling of your compute layer, which Dremio is really flexible in that regard. So again, it depends on your specific use case, how you want to architect that. And then there was one other thing I wanted to say. But yeah, it's as far as like benchmarks go, what I would recommend people do is that we have an annual conference called Subsurface, and in the opening keynote by our CEO Sadhu Kumar, he actually went over some of recent benchmarks that Dremio's had against some of the more competing engines of this type for this kinds of use cases, and they're pretty compelling. But I don't have the exact numbers off the top of my head, but they can see it really nicely, well presented, and a really, really attractive, catchy slide in that whatnot. And we do have a couple white papers that were issued recently that also have a lot of information regarding those benchmarks.
Yeah, I think for me, it's more about benchmarking against actual database engines that are generally built for that, transactional nature versus trying to squeeze out, this, essentially it's a cache. Sometimes people just need a fast cache. So I know we have only a few minutes left, so I'll leave the best for last. And I asked the same question to anybody in the data space. I've asked this to two big database vendors, and one of them actually, I think, went in the right direction, and another one is kind of ambulating along. I see that you have a Gen AI text to SQL, which is awesome. In the overall, Gen AI space, and I think that's very important, because if you have all of the if you have all the metadata there, like what else? Why else would you go somewhere else to do this text to SQL, right? It doesn't make any sense. Like, you have everything there. So what is the outlook for either Dremio or actually lower level at the Iceberg level, for vector data type, for the purpose of embedding and inquiry? And I know it's not necessarily like in the wheelhouse, although some of the data warehouses are kind of getting into that slowly. But what does that look like for you guys?
I mean, basically, we're going to track very closely with where the Iceberg standard goes. So like probably like things that are in the horizon are things like the variant data type for Iceberg, whatnot. There has been discussion of sort of vectors for Iceberg, like vectors as a data type.
Yeah.
But I haven't seen any proposals recently that show that that's like a near term thing.
Mhm.
But in the future, that I would imagine that would be where that begins. So a proposal to the Iceberg specification on how you would represent vectors within that, which would again probably have to coincide with some discussions of how Parquet is done,
Yeah.
since the data is fundamentally stored in Parquet. But once you have that, then you have the pieces for any platform that works with Iceberg to essentially become a vector store and allow vector handling. So I mean, right now we don't look at ourselves as where you do the vector processing. We look ourselves as how do you serve the data for training. So essentially,
Yeah.
like you might have lots of data in lots of different places, and you want to prepare it for training. You could Dremio makes it easier to unify that data and model it, and then using the different interfaces, JDBC, REST API, Aeroflight, you can pull it into your notebook and train your models against that data, and then you go from there. But right now, we're not necessarily in the vector store game.
Mm-hmm. Mm-hmm. Yeah, I think it's a less of a right or wrong thing, and it's more of like, and this is like looking at all the different vector databases that are out there now. There are those that are natively vector databases, and then there are those that they were databases before,
Yeah.
NoSQL or relational, and then they added on this layer to be a Me Too vector database. Some being probably as good, if not better. And I'm telling you this, my opinion. I think that the value of having a vector data type in something as vast as Dremio would potentially save a lot of cost, especially from the perspective of like how you guys already do a lot of cost optimization. Whether or not you actually take on the embedding task, some databases you give the LLM, local LLM, or like a remote LLM. Here's my key for my remote LLM, and so you put information and it vectorizes it. I think that's an opinion, but
Yeah.
in terms, yeah, go ahead.
No, to say like, yeah, I mean, there's different ways that could be possible. I'm not a product manager, so I can't speak to what's on our currently on our roadmap. So,
Yeah.
but I mean, I can imagine like one route would be again the vector type in Iceberg. I would say that's probably more likely what the eventual Dremio story would hinge on. But there's also again there's like new file types like LanceDB, their file type,
Yeah.
and that could be things that you can support to help get access just to some of that. Again, I mean, I will leave it to the product managers to determine sort of like where the future lies. There are exciting things that I am aware of, but of course, I have to be quiet for now. But bottom line is like the way I would think of like Dremio, if you have multiple data sources that you're trying to unify to serve for purposes. So in the case of AI/ML, I would think more, okay, hey, if you're trying to more easily prepare your data to train your model versus store the vectors on the other side, that would be where I'd see Dremio for the moment. And then also if you have like you have a hybrid situation where you have data on-prem and cloud, you're trying to get better unification across, Dremio is going to be sort of a slam dunk. And that would be sort of like in that, and this, and then if you have like basically you want to serve better BI dashboards off your data lake. Dremio is also a slam dunk there, because it leverages what you already have. Like it basically plugs into whatever your existing infrastructure is, making it a nice piece to complement your existing system. We're not something that you have to say, hey, look, I'm going to get Dremio and I'm going to rip out all this other stuff. That happens sometimes, like depending on the situation. But there's a lot of times where people just add us in there. There's a couple of use cases where, hey, this works really well for these 3 use cases that we have, and it just becomes this nice piece that just makes their entire story of everything they have more useful. Like I mentioned, like the offloading section, like there are customers who have SQL servers and literally they're using Dremio just so they can run queries across those different SQL servers that they have. And that's one use case. Or one customer that's literally using Dremio just to run SQL on Elastic. So that way they can use SQL against their Elastic data instead of using like Elastic's language. So there's different odd bits and bobs because it's such a flexible tool, but it's not necessarily like it doesn't have to be the end all be all for your data platform. It can be. You can definitely build a robust Iceberg Lakehouse with Dremio at the heart of it, but it usually has a place somewhere. Like usually it's a Swiss Army. I like to think of it as like a Swiss Army knife where there's some blade that'll fix some problem that you have probably. So when we want to have a conversation about what those problems are, if we do free workshops to kind of discuss, hey, what your situation is and see if there is a fit. And again, we're not going to tell you, hey, use it for this if you don't need it for that, but we'll see, hey, is there a situation that makes sense? Is there a fit? And those you can go to like dremio.com/contact to do that, you'll be talking to one of our solution architects who are really even finer grained, like knowledgeable about like the different applications of like things like reflections and fine tuning the Dremio query engine and the SQL and all that stuff.
Great. Awesome. Well, thank you again for joining us, and thank you, Obi. Any last words?
Yeah.
Go ahead.
I'm just gonna say, everyone follow me on LinkedIn, Twitter. I'll see y'all later. Thank you so much for having me again.
All right. Yeah. Thanks again. Remember to like the video and subscribe to the channel, and we will see y'all next time.
Take it easy.
All right. YouTube stream is ended.